Hello. In this video, we're going to go over a few strategies to help you manage your dependencies in a Unity project. Basically, this is the video that helps you make your project not a giant pile of messy spaghetti code. So let's get started. I'm going to assume that you know about scriptable objects and about events. I'm going to show you some things that you may not have, dug into super deeply, but you'll be able to sort of look up. And this is all going to be very high level, I guess is what I mean. So with that said, let's begin. We're going to start with an example to really go over what I mean by dependency and how we're going to visualize them and graph them out. So here I have a character controller and I have a character controller input. The character controller input grabs that character controller and calls a function on that character controller every frame. So if this were null, if it wasn't able to do a get component call, then it would just break. It would just completely break. And that makes sense. That's how input should work, or can work. And if I go find my player, I can see I have my character controller and all of its settings and my character controller input. And sure enough, when I hit play, we'll be able to take this little raccoon character and, run around. So if I want to visualize that, I can do that with a diagram. So let's start with our scripts. We have our character controller. And we have our input. So I'll draw those as nodes in a graph here, and I will connect them with a directional connection. And I'm going to use an arrow to represent a directional connection where things are pointing to what they need. I need this or I will break. I need that or I will break. I need this ingredient or you cannot bake this delicious cake. So we will draw an arrow from input to controller. And similarly, the controller uses a rigid body to move. So there's a rigid body, RB, rigid body component as well. So as you start graphing these things out, collider, and the interaction handler, I'll call H. You can start to see where you might have really long chains. Here, the longest chain is from input to controller to rigid body to collider component. So there is a indirect dependency on a collider component that the input script needs. And those two things are pretty unrelated. One handling physics collisions and the other handling, player input. But if you look at it and you think to yourself, maybe that's fine. But making diagrams like this one is very helpful to find sort of longer than expected chains of dependencies. Or let's say you have some other system over here, like UI or game manager or something else. And for some reason, there's like some random one long connection, these things are all talking to each other and these things are all talking to each other. But for some reason, there's something reaching over and needs some little piece of data. You're like, oh, that's a problem, because now you have a super long dependency chain. So you generally want to keep these sorts of dependency chains short. And that's one of our main structures. We want to minimize dependencies wherever it's possible. We can't get rid of them, otherwise our game wouldn't work. But we want to minimize them wherever possible. But fighting complexity is less a task of deleting dependencies and more a task of managing and manipulating them. So today in this video, the strategies I'm going to show you are strategies for sort of changing how these things are all connected to each other to keep your game from getting so messy and spaghettificationated. Trying to come up with a stupider name. I hope one of you was extremely bothered by the fact that I said stupider. Okay, let's get started. Let's get started with the first pattern, and the first pattern is a manager pattern. The manager pattern. And the manager pattern takes a lot of sort of small systems that are all talking to each other, and it puts them inside of one system where they can be as messy as we want between each other. But this is a strategy to use if there's one weird piece of data that some other system somewhere else needed, that one reaching into the middle of the pile. Instead, we'll wrap everything up with a manager so other systems in our game can go talk to it. I am using a manager pattern in my project in a fairly simple location. It is in my status display, which is this UI panel right up here, where this screen can look at a bunch of different things. It can look at events that are coming in. It can be where you're going to load up your settings. This is going to be an AR game for the Tilt 5. It's going to be each player is going to have their own little screen in front of them, and they can sort of switch through and just hide it. But I needed some way for the, you don't have a computer screen. You just have these AR devices. I needed something quick and easy to do settings and to do debug messages and stuff. So I have, with the way the manager pattern works, whoops, let me go to here. The way the pattern works for me is I have a single display, display screen, I think is what it's called in my project, but we can call it display manager. And then as a child of it, I have sort of the info screens, that's going to be my settings screen. It's going to be my player customization, choose what hat your raccoon is wearing screen or whatever. And they are all going to have a reference to this manager, and maybe they also have references to each other or some other, maybe there's some other button, next page button that talks to them or something like that. And it's messy, but it's all sort of contained inside of my display UI system. And then any system on the outside of that, like my player or my input or whatever, it is only going to talk to this interface that is the display manager. We'll just cut off the word manager. This is how my diagrams tend to actually look in real projects too. So what I'm avoiding is something sort of cutting into the middle and cutting inside of one system. And what this allows me to do, the way that this helps me fix bugs, is it allows me to change up how all of this UI stuff works, replace it with something else, and I only had to touch the code that was inside of that UI system, and I didn't have to mess with any code anywhere else, because I kept the interface between them, whatever functions that we're using there, the same. So the manager pattern helps me there. Game manager that manages like the timer and the paused state and things like that, very common. Having a player script that knows its inventory and character controller and input system and interaction system, very common. Haven't done that for this project yet, probably will. It would be probably helpful. Anyway, my manager here is called status display, and it keeps track of everything. It has references to external systems, and it knows what screen is visible, and it tells that screen, you are turned on, you are turned off, and each screen, and I've only written one so far, gets turned on and gets turned off and so on, and it deals with itself. Very convenient, and it doesn't reference anything else really directly outside of its system. All of its dependencies and references have to do with, the messages and the UI stuff. If it needed access to anything, it can go through that manager class to get there. Strategy number 2, besides the, let's write up here, 1 is the manager, 2 is data oriented. So let's go back to a much simpler exemplar. And the ship has an actual variable here of its health, but we need to display that on the screen. So somehow we're going to have to connect these two systems, the ship that knows what its health is and the user interface that displays what the health is. And our options are, we could have the ship call a function on health, update UI, makes sense. Or we could have the health talk to the ship and say, hey, what's your health? Okay, thanks. And so on. Either of those might work, and we just have to decide which one we want. So if I were to have the health look at the ship and talk to it, well, if I were to get rid of the of the UI, the game would still work. And if I were to, but if I got rid of this ship, the game would not work. And if I had that the other way around, where the ship broadcast out to the UI, well, then if I got rid of the UI, everything would break. So the general question is if it can kind of go in either direction, if it doesn't really matter how it works, then the question is like, what is more fundamental? What are we more confident we're going to have in our game? And I think turning the UI off is probably going to happen. So it makes sense in this case to do it this way. But it still kind of sucks. And a lot of developers have made this code and written this thing and gone, dragged the dependency and gone into Unity and dragged the script into the slot and gone, and they sort of looked at it like, I just added a little bit of spaghetti. But one noodle's fine, one noodle's not going to hurt you. One noodle's not going to, going to ruin your diet. Like, you're going to be okay. But maybe there was some way to avoid this. Yes, there is. Data-oriented design. I'm burying the lead. We're getting there. It says it right here. You know where it's coming. And this approach is to actually move that piece of data, that float or integer, whatever variable, into another data object. It just represents information, and sort of pull it out to an intermediary, right? Sort of like the manager class sort of pulls out a dependency to an intermediary, a manager. This one pulls it out, but it puts it over to the side. And this doesn't look like it's actually solved much. It has removed the dependency between health UI and ship. We can get rid of the UI, or we can get rid of the ship. The game will still work. That's amazing. I absolutely love that. But it does require this object, this data object. This needs to exist in order for us to do that. So if only, and you can see where I'm going with this, but if only there were a way to manage an object in Unity that was extremely convenient and that didn't get destroyed every time I loaded a new scene or restarted the game, and I could manage between multiple scene loads, and I could reference by prefabs, which you can't reference scene objects by prefab. Oh my gosh, where am I going with this? It's a scriptable object. We're using a scriptable object as our intermediary data layer. They're always available. They're just in memory when the game is loaded, depending on asset bundling things. We can reference them from prefabs. We can just talk to them, right? Talk to the ship info, talk to the timeline, my other scriptable objects. I'm not going to introduce scriptable objects to you, as I've already mentioned, but I will show you them real quick. Where are you? Where'd you go? Here. My ship info. It'll have a few more things as I work on this project, but right now it just has health. And it has a way to look at that variable. It has an event. Ooh, that's coming up next. And my ship, whenever I take damage, there it is. It updates that ship info function. And on my health UI, which is up top, this is a very simple script. I have a text component, and I set its text value to the health variable of ship info, and I don't even know what a spaceship is. I could make my UI in a prefab. I could make it in an empty scene or a UI scene, which I love doing that. Additive scene loading, oh, so good. And I can delete the ship, and I can test my UI without needing a ship, which means multiple developers on different teams. One is working on the ship graphics and connecting everything, and one is working on the UI. Those are two different developers working at the same time, and they're not fighting over the same scene. You love that. So that is the data-oriented design pattern, is to move things away from either of the objects into a more convenient location. So let's go on to our third strategy, which is just events. So if you were to look at my project, it has this sort of game manager class called a timeline that manages sort of when all this stuff happens. A new asteroid is incoming and everyone needs to know about it. The ship needs to know about it. It needs to get hit and take damage, and the players need to know about it. The UI needs to know about it, and it's all over the place. So the way that it is currently set up is my dependency graph zoomed in probably looks something like this. A lot of different objects somewhere else, my ship and my space stations that you push the buttons on my UI. All these other things elsewhere are all looking at, oh, let me just draw one more box, are all just looking at this one system. It would be really unfortunate if there was one arrow going the other way. There is, it's to a state machine, and I don't care about that. But if there was a dependency, and that chain were to keep going, because suddenly 1, 2, 3, 4, 5, 6 boxes that I've drawn are all now dependent on this object existing, and that's really unfortunate. So when you're trying to sort of fight these long chains of dependencies where all of these different systems are dependent on each other, and especially with the manager pattern, it can be really helpful if we were able to erase this dependency or flip this dependency around so that it were going in the other direction. And then we wouldn't have that super long dependency chain, and then my game would not need 8 million objects to even hit play without breaking. So events are a strategy for taking dependency that's going in one direction and making them a dependency that's going the other way. So where normally you would have a function call, let's go down and take a look. Normally you would have a function call where the on start might tell the UI, hey, start, and it might tell the particle system to init, and it might tell the player to enable input, and it might tell the background music to start playing. And suddenly this one game manager that starts the game needs to call a function on all of these other objects. And yes, in Unity, you can avoid that with separating things into different scenes and using the scene start functions in a scene load to help you with that. But what we're going to do is instead, we're just going to draw one big arrow here, flip that around the other way using an event. So we do that in C# using a tool called a action. There it is, a tool called an action. So an action is a C# feature. There are many other ways to do events. There's Unity event, serialized events, there's events, delegates, blah, 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 blah. There's a lot of ways to do it. And there's also actions, and making them static is a really convenient pattern. So let's keep that in mind as well as you learn about them. Not going to cover it here. But here I have sort of on timeline started, on ship event, on beat, on new beat. I have these different actions. And let's see, only the warnings UI is using on new beat, but on beat is used by status effects, and on timeline started is used by the message system, and on ship event is used by the ship and also the message system. But as the game continues, there'll be a lot more that are all these different things talking to this one object. And when the game begins, it doesn't know about the message system at all. All it knows is that I'm going to call a function. What function? I don't know. Whatever functions have subscribed to this event. And over in message system, it's going to say, whenever you call that invoke function, what you should actually call is my function, sort of indirectly, right? So an action is like a function call variable. Helps you think of it that way. So now, my game timeline, it doesn't have any outward dependencies. It only has sort of inward dependencies, because if there's no one subscribed to this event, and it just says, okay, whatever. It can just, live in a dark, lonely hole. So yeah, that's the event system. Sort of the other objects will now go look at the timeline, find the event, and subscribe to it. There's your dependency. And then all this does is invoke. And then those other functions get called. And that's great. So last time I did this, Unity crashed, so stay with me here. If I look at all the references that the hierarchy has on my timeline, yeah, there it goes. Look at that. Look at these errors. There's a bug here. I can find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 different objects in my scene that all reference my timeline. And it's fine, because my timeline has references. It doesn't reference anything that is not also just a different scriptable object, and it's sort of this configuration area for my game. It's great. Cool, I broke Unity. That happened to me before. I submitted a bug report. They got back to me like, we know it's getting fixed. So anyway, in conclusion, 3 events for managing are dependencies, a manager pattern, which allows us to compartmentalize complexity and allows us to sort of iterate and make changes with one system without having to rewrite or mess with a bunch of code in other systems. It gives us sort of a clear interface into systems. A data-oriented pattern where we sort of take some referenced by many separate system piece of information, we separate it into a more convenient to reference area. We have other things reference that, and then we use either a singleton pattern or scriptable objects to reference that information, or an event system where we can sort of flip dependencies around. There are many other advantages to event systems besides flipping dependencies around, but that is the one that is in the context of here. Makes sense. I hope you found this video helpful, and I will see you in the next one.